Hey, how's it going there, Styler?
Hey, how are you?
Doing good, my friend. Doing good.
I'm great. Did you notice that our project was rejected?
Yeah, so yeah, me and Wendy actually we had a discussion about it. So what happened is that it was rejected, but yeah, well, here she is right now. There you go.
Hello.
Hello, hello. So Wendy, so you ended up actually talking to Brother Bennett, right? Is that correct?
Yes. Yes, I did.
Awesome. All right, so I realized that I know that our first design it was rejected.
hmm
So did he say anything regarding that or?
Yeah, I asked him why it was rejected, and I get that it was rejected because this we put the population was going to be kids, and he says federal law you can't do a study on kids, which I got all that, but when I explained to him that it was we weren't going to talk to the kids, it was just what they chose for lunch. He
Yeah.
said to go through that IRB. Is that what it was called? I don't know. I emailed you about it, and if they approved that we could use just the statistics from that we could use it, or
Awesome.
to rewrite the plan and make sure that we notated in there that we got permission and that no kids were going to be surveyed. Um, and then he said just to rewrite it that way, and that
Awesome.
it would
Okay.
be fine.
Okay. Yeah, because man, it's kind of a but he said that I guess we lost those marks just regarding it wasn't approved.
He didn't say that. I think
Okay.
it. I think as soon as it gets approved, we will
Then
get the
he'll.
20 points.
Okay, good. Awesome.
Yeah.
All right, because it was weird because I sent that. So I remember on Tuesday we talked about it. So
hmm
that very day, so that's good that that won't happen. Just because it was 3 weeks ago that I sent it in,
Yeah.
and it took him a while for him to get back to us. So that is good. All right.
We never did talk grade wise, but he was talking to somebody else when I got on there, and he made it sound like that just resubmit it, and when it does get approved, that your grade would be fixed.
Awesome. Okay, way cool.
So
Good.
yeah, yeah, yeah.
But thank you so much, Wendy. Like that's amazing. Thank you so
No,
much for putting in the effort in.
you're welcome. I just happened to be home yesterday, so I was like, hey, I will look at this stuff.
So
So good.
So I actually was able to take a look at it, and well, I think it's amazing. That's great. I think the only thing is that I think you had a question about if we should do a cluster sample. Is that what you're thinking about, or?
Well, I just don't know what it is because he was like he goes the only hang up I have a little bit is you're not gonna really collect it, like you're not collecting the data from the people, like you're collecting it from the computer. He
Mhm.
goes, so with it only being 27, I would feel better if you did your study with all 27 sites with the one proportion and make it the fish sandwiches and not the pizza, because of course everybody's gonna like pizza.
Yeah, that makes sense. So he just said basically do one proportion for the fish sandwiches.
hmm
Yep, that makes sense. Perfect. All
So then
right.
I didn't know because it wasn't like a random or systematic, pick this or that. So that's why I put cluster, and then I deleted like the null and the I don't know towards the end.
Nope. Hey, that's perfect. Thank you. That
hmm
is terrific. So you were just thinking how we're gonna do the cluster.
Right? Is that what it is? If we use everybody in that age group in a school district?
I believe so. I mean, like, that's a good question. I actually have to research what exactly that means. I
Okay.
mean, but he said that you couldn't do a systematic. Is that correct? Or
Well, he just said to use everybody, so I knew it wouldn't be systematic at that point because it wasn't. We weren't just narrowing it down to 6 schools any longer.
oh yeah, because we're using all 27 in schools.
hmm
Intense. All right. Well, let me. I'm just gonna see.
I'm trying to pull that up.
Yeah, me too. That is terrific. That that we don't get the 10 points off. Yeah. Because I was just gonna say, man, I sent it 3 weeks ago. What's going on?
Right? Yeah, and if he would have got back to us sooner, we would have revised and figured it out and fixed it.
Yeah, exactly. But
Oh.
that's terrific that everything worked out. All right. Cluster SAML is all items in one or more randomly selected clusters or blocks. Okay. Oh, okay, all right. So I got an explanation here. It says, for example, a researcher wants to survey academic performance of high school students in Spain. He can divide the entire population into different clusters, cities. Then the researcher selects a number of clusters depending upon his research through the simple or systematic random sampling. So I guess that's what we could do is that I guess the one thing that we could do is that we could divide the 27 schools into 4 different populations. And then, yeah, then basically from there, we have, like, for instance, let's see, 27 divided by 4. So we would probably have 6 different, at least there'll be 6 different probably schools in each group. And then basically from there, we would choose 2 of them, if that makes sense.
Is that still for the one proportion test?
Yeah, it's still for the one proportion test, yeah.
Okay.
I know. I'm not completely sure though. Because I know that he said that maybe a cluster would be a good idea. Eh?
I didn't ask him which test sample it would be at that point. That was just me from what I was thinking at that point, just of it, because it isn't like a cluster, just a whole group or block of things. So for all of Weber School District, this is the block of elementary schools.
Yeah, that's right. That's a good question. I guess we could do it that way. We could just divide all the schools, all 27 of them, into different clusters. And then basically we could select maybe 3 groups out of. You could even make more groups if we want to. I mean, if we did 6 groups, so 27 divided by 6. So we'd probably have, if we divided them into groups, we could basically divide them into 6 groups. And then from that, there will be at least 5 in one group, and then 4 in all the other ones, right? Mm-hmm. And then from there, we can actually select. So from those 6 different groups, we could probably select at least maybe 4 of them, just from basically systematically we could do that. And that I think that would still be compared. I think that still would be a cluster sample if we did it that way. What do you think about that?
Yeah, I think that's fine.
Yeah. All right.
Yeah.
Awesome. So the one thing I'll do is that I'll kind of explain that. So I can actually rewrite, because you already kind of practically rewrote a lot of stuff, which is fantastic. Thank you.
Mm-hmm. You're welcome.
So then I'll actually I'll rewrite basically step number 8, and then I'll talk to actually Brother Bennett on Thursday regarding it too. So I'll basically tell him what we're doing, because I think that for this it's not due till Saturday. Is that correct?
The data is due on Saturday.
Yeah. Okay.
But,
Data is due on Saturday. Okay.
Yeah, and I'll collect the data. I can work on that tomorrow here.
Okay.
And get that going.
Intense.
And should have it all.
Because I know that his office hour, like, did you talk to him in his office hour on Monday? That's right?
Yeah. Yeah.
Yep. Awesome. Okay. So I'll talk to him through his office hour on Thursday, and then I'll see if I can basically try to get something done with that for sure.
Okay.
Because it is quite confusing, because like we originally wanted to do systematic sampling, but yeah, not too sure if that. I guess it could technically work. I'm not completely sure, but we can go.
I think he was just more because it was so easy to collect the data. He wanted us to collect more of it, so that's why he said to collect all 27 schools. Because then it would for sure be, it would for sure be big enough to be evenly proportioned.
Yeah.
Normally distributed.
Yeah, that's true. I'm just wondering what kind of sampling that would be, though.
Yeah.
Yeah, that's a good question.
I got a question.
Yeah.
When you generate, will it be in Excel or does it make sense what I'm asking?
So Stan, I think you cut out just a little bit, my man. Would you be able to repeat that, my man?
Okay. When you're collecting the data from the system, I imagine it's in the system somewhere, isn't it?
My data, how much of it is in the system?
Yeah, where is the data?
The data is in my school district system. So I was just going to put it on a spreadsheet of, school number, they served X amount total, and then X amount fish sandwiches.
Exactly. So you could have it in an Excel spreadsheet. So I wonder if whether in that student. So if it's so, from in the spreadsheet, Excel has a way to take random numbers. So if you have a range of, for example, if the first student ID is 100 and the highest student ID is, for example, 1000, same something. You can tell Excel, pick me 10 numbers from this range, and it will highlight you randomly. So with Excel, you can take a random sample easily. So the thing we need to calculate is the sample size based on the level of significance we would like to have.
Yeah, that makes sense. Because then what we can do is that if we collect all of the data from, I guess, 27 schools, and then we can select, I guess, random numbers out of the population. Is that what you're trying to say, Stylen?
Yeah.
Okay.
I wondered. I don't know. I'm just thinking.
No,
For
no, no.
example, if you make clusters and you, for example, you isolate each group of school, and inside those groups you also do those random selections, filling the requirements for clusters, because you have to take randomly each the selections inside each cluster, I think. So I don't know if the data is already in a spreadsheet, Excel would help us to do easier to generate the sample size or the sample, the each student that we're gonna measure.
I see. So does Excel actually have a setting that allows you to select random numbers? Is that what it does? Does it have a setting like that? It does, right? Okay.
Yeah.
Yeah, there's a formula say random. So you put they call that like the I don't know. It would be like each student has a specific number.
Mhm.
Would be easy.
Yeah, that actually would be probably a better idea for sure. What do you think about that, Wendy? I mean, the one thing we could do is that we could use Excel. If there is, I'm not completely sure. I mean, if there is a way.
There is. I've seen the professor use it recently in one of his videos. He used random.
Yeah? Awesome.
Mm-hmm.
Okay. Then we could definitely do that. Then if we did that out of the data, then I think that'd just be a random sampling. So it'd be easy for us to basically get the sampling for sure.
Yeah. Yeah. Perfect.
All right. Well, then that makes it easier for you.
Yeah. Yeah.
All right. But if you want me to, I can still talk to Brother Bennett about that too. Just saying if that would be a better way of doing it. What do you think, Wendy? Do you think that's good or?
Yeah, or either whichever one you want to do. I think Stone's got it right. I think that'll work though too. The way that he's explaining, if you just write it in the paper that way.
Okay. So the only thing that I have a question about is that I know that like you can randomly select numbers from like 1 to all the way to the amount of numbers that we have, right? But what would be the most appropriate number for us to go to? Because let's say that you had like 1 out of 1,000, right? Would you take 800 numbers or would you take 600 or 700, right? Because you have to basically take less than the amount, right? In order to collect all the data. Is that correct? So we have to maybe 50% of it or 60%. That's my question. So, but I think, you know what? If I can talk to Brother Bennett about that, and Wendy, if you need help collecting that out, just let me know. But I'll talk to Brother Bennett about that. If he wants 50% of the data or if he wants more of the data. But I think that's good for the study for now. What do you guys think?
Another option would be, I don't know if you remember that we learned there's a formula we use to calculate the sample size. So with that formula and the level of significance we want to treat the data, I think we can calculate actually the sample size we would like to use and everything. I don't know. I will have to remember the variables of the formula, but I think we already learned a way to calculate the sample size.
It was in lesson 16.
Yeah, that was, yeah.
So it's the N and the P and the Z and the Q and the X. No, just kidding.
Yeah. So how would we do that then?
Then it's I just looked this up last night because I was looking. Oh, I lied to you. It's in 17. So it's N equals the level, like the Z level of significant divided by M squared times the population and then times 1 minus P It's in level 7 or lesson 17 down at the bottom in the review or the recap.
Yeah, I see that right there. Interesting. The only thing is that we don't really know what M is, right?
The margin of error. No, I don't know.
Yeah, I'm not too sure what that is either. I mean, we definitely could still. Yeah, that's right. Well, So if we look at basically, you know the n p hat, it's the equation that's greater than 10, and then also the n minus 1 in p hat. I wonder if basically if we take the whole all of the numbers, so the whole population, and then we can calculate what's the least amount of data that we can use to basically make up for the population. Does that make sense? Because if it's greater than 10, then that's fantastic, right? But I'm pretty confident we'd be good. But if we come up with a number, let's say, for instance, if it's 80, or like if we use I'm pretty sure it might equal to the amount of that we're looking for in doing the study, I believe. So I'm pretty sure that's the equation means. So what it's basically stating is it has to be greater than 10 in order to use a formula like this, right?
Yeah, but there is that one. Well, it talks about it in the review. Should we go do the review, and then it might be clear for all of us?
Sure, we can definitely do that. All right. Let's do that then. Okay. All righty then. So Clinton said he's on. Okay. All right. Everybody there, or? All right. So we'll start. Yep. Awesome. All right. So we'll start with question number 3. All right. I'll start us off. A human resource manager reported data from a recent involuntary reduction in force, RFI, at her company. You are an attorney and want to determine if the age of discrimination was a factor. It is illegal to discriminate against employees because of the age. The company reported the number of employees into 2 groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypotheses test would be most appropriate for this analyst? So there is one sample t-test, paired sample t-test, independent sample t-test, ANOVA, test of 1 proportion, test of 2 proportion, and chi-squared test of independence. So I'm going to go with a wild guess and state that it would be a paired sample t-test.
And I wonder if it's a test of 2 proportions, because it's 2 different groups.
So test of 2 proportions.
Yeah, because the company reported the number of employees in 2 groups, 40 years and older, 40 years and younger and 40 years and older.
Yeah, it very well could be that, that's for sure. Let me double check. To determine, but I think it's looking at the age of discrimination was. Oh yeah, age of discrimination was factor. It is legal to discriminate because the employees reported.
But so I am terrible at picking what sample, what test to use. Just I know I need to do better than that.
Oh, no worries. I have to do better too. I think it might be because we're looking if it's chronological or if it's if we're looking if it's quantitative, right?
Right.
So the thing is that I know that if we're using chronological, if there's no numbers that are used as a factor, then we'd use chronological.
Okay.
But since I think there's one thing, so it says the company reported the number of employees into two groups, right? So I think that reported the numbers of employees. Actually, what are the numbers regarding? I think the numbers are regarding the ages of the two groups. So we go 4 years or younger and over 40 years. They also report the number of employees in each group who were terminated. Interesting. Okay. You know, it could go both ways. It's a good. I think it could be quantitative just because it's relative towards the age of people. But you could be right. It could be to proportion. But I'm pretty sure it'd be quantitative though.
Well, it'll be the mean then, right? So it'll be the mean of their ages. No. Yes.
Yeah.
Star, what do you think?
I think is you mean they are comparing the two hypotheses. For me, it's a paired sample test.
Perfect.
Okay.
Is one related to the other thing?
I believe so because if you look at because the attorney is looking at the data that was recorded by the human resource manager, right, for the same company. So I think it would be relative. It would be a pair sample t-test.
Perfect. Let's go back up to number 2.
You sure?
Yeah.
Oh, frick. My bad. I skipped one.
Oh, good.
All right.
Okay. In an article in the Journal of Small Business Management, successful startup business of the United States and Korea were compared. One set of data compared education levels, high school, undergrad degree, master's degree, doctorate degree of people who managed successful startup companies in the United States or Korea. We want to determine if education level was education level of manager of successful startup companies is independent of the country they are from, United States or Korea. Which hypothesis test would be most appropriate for this analyzation?
The last
Because of
one,
what the last one?
Yeah,
I
it would
think
be
I
that
don't
one.
know.
I think it would be that one too. Just because they're
The Kai?
looking, yeah. Because what they're looking at is they're looking at 1, 2, 3, 4 different groups, right? And they're looking at the levels of education, right? So basically,
Right.
it's nothing to do with numbers whatsoever, and it has to do with basically the chronological. So the chronological things, which is basically high school, undergraduate degree, master's degree, and doctoral degree. So yeah, I think it would be the Chi test.
Well, and in the question it asked independent, and in the Chi test it's like the Chi test of independence. So it's either
Yep.
all the same or independent.
Yep.
So
Kabam.
I think we're right.
I think we're good.
Sweet.
Awesome. All right. Question number 4. Stein, would you like to read that one, my man?
Sorry.
Awesome. Oh, no problem. I'll go for it.
Okay.
All right. Our survey. Oh, hey, what's up, Clinton? All right.
Sorry.
Oh, no worries, my friend. So I'll go with question number 4. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5. Which hypotheses test would be most appropriate for this analysis?
Is it test of one proportion?
Yeah, I think it would be that one also.
Yeah.
Oh, Spelling says yes, we're good.
All right. I guess we're good for that one. All right, question number 5. Stein, would you like to read that, my man?
Yeah. A student
Awesome.
project compare the effectiveness of two different combination locks. One of the locks turned clockwise first. Locks turns counterclockwise first. They asked 25 students to participate in the study. Each student was given the combinations to each lock and asked to open the locks. The time it took then to open each lock was recorded. They want to determine if one of the locks is easier to open. Which hypothesis test would be most appropriate for this analysis?
So Quentin, you're
Pair
here.
sample t-test.
The independent t-test.
I think.
Mm, no, because there will be. Do you remember the hypothesis test for you? Find the difference between the two means.
Mm-hmm.
Which one was that? I don't remember. But I think it's
The difference between the two means, it could either be a paired or an independent.
okay.
Yeah, I think it might be paired sampling t-test just because the 25 students, right? There's 25 students in total. And I think that, for instance, let's say that you have one student, right? And the one student, let's say if they're being slow at doing the combination locks, right? Let's say just any person, like let's say that they don't use locks that much. So I think that it might be paired just because that same person might be slow, right? And both basically doing both combination locks. But if you look at a second person, right, if they're fast, right, they'll be able to basically do the combination locks faster, and maybe one would be less than the other because maybe one is more difficult, right? And what we're using is actually we're using 25 students that are I guess the 25 students are using 2 of the locks, right? So so the students are the same. So I think that it would be paired. That's how I think of it. Yeah.
I just thought it would be independent because they're just finding the mean of which lock is fastest, not like lock number 1 minus lock number 2, and you get the mean that way. Like,
well,
so I did the independent just because it is just one independent lock, and it doesn't matter what
no,
they got on the other one. So I don't
actually, nope. Hey, well, that is a good point.
know.
We shall see what happens.
Yeah.
That's right. When we submit it through, then we'll end up knowing.
True.
So.
Okay. Here we go. Number 6. We're gonna.
Oh, go for it. Is
Yeah,
Clinton there, or Clinton? Are you there, my man?
His mic's off.
Oh, okay. All right. You go for Wendy.
Okay. This is for the next 3 questions. We're getting the confidence interval. Where's what we're finding? Okay. The bank employs 2 appraisers when approving borrowing for mortgages. It is imperative that the appraisers value the same type of property together. They make sure this is the case. The bank evaluate 6 properties that both appraisers have recently viewed or valued. Which confidence interval would be the most appropriate for the study? On this one, I put the paired sample t-test because it was the 2 appraisers together.
Yeah, I'm thinking
same thing.
I think you're right. That's pretty much what I put too. Yeah, these questions are always tricky.
Mm-hmm.
I'm pretty sure it's paired though. All right. So question number 7. Are you good with that one, Stylen? All right. We will move on to the next one. All right. So question number 7. In a Wall Street Journal article on satisfaction. Yep. You're good. All right. Legit. Awesome. Okay.
I think so.
Okay. All right. So we're on number 7. In a Wall Street Journal article on satisfaction, which career paths the percentage of physiological majors reported they were satisfied with the career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% convenience interval to see if the observed difference is significant. Which confidence interval would be the most appropriate for this study? I think it would be 2 proportion.
Because it's 2 different degrees.
Yeah.
Different career path.
Yeah, that's what I'm thinking, because there's 2 different groups right there. There's the one that were satisfied with their report. I mean, both were satisfied, but they did this a different group for accounting majors. And well, they do 2 groups. There's physiological majors and accounting majors. So that's what I'm thinking. Could be right, could be wrong. Hoping I'm right.
Yeah, I think so. I think it's 2 proportions.
Okay.
Perfect. Okay, the next one.
All right.
Double stuffed Oreo cookies were supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if there is a true whatever by the company who made them. You take a sample of 55 double stuffed cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount for double stuffed Oreos in order to compare it to the filling amount to regular Oreos. Which confidence level would you use? I put a 1 sample Z, because did it say that the mean was known, or that they knew it was twice as much as the regular one?
That is a good question. I think it could either be what you said. It could be either the 1 sample Z confidence interval or the 1 sample T confidence interval. Because they're just trying to look at one mean, right? Because they're trying to figure out what the mean is. True session by the company makes a sample of 55 cookies and measured the amount of filling in one confidence interval. Estimate the true mean. So they're trying to figure out the true mean, filling the amount of the double stuffed Oreos in order to compare it with filling the amount of regular Oreos. So I think that they don't know the mean quite yet.
So the 1 sample T.
Yeah, so I think it would be 1 sample T.
Perfect.
All right. Okay. All right, question number 9. Which one of the following best defines the notion of significance level of the hypotenuse test? So which of the following best defines the notion of the significance level of the hypotenuse test? Would it be the probability of type 1 error? Would that be it? Oh, is Stylen still there? Oh no.
He left.
Okay.
I put. What did I put on that? I put A.
the probability of observing sample statistics more extreme than the one actually obtained, assuming the hypothesis is true. But would that be the p-value of the hypotenuse test?
That might be.
Yeah. And then they're very similar questions. That's why it's kind of up in the air.
Stan's back. What do you think for 9?
I think it'd be the probability of the type 1 error. I'd have to look it up though. Yeah.
Sorry.
No problem, my man. Not a problem.
I got a question. I went off the number 8.
Number 8. So we put for number 8 one sample t confidence interval. I'm pretty sure that's it.
T or C?
T. The second one.
T.
Yeah,
The
so
second.
T. Yeah. Second one, yeah.
Why not the first one?
Why not the first one? Because I think what I think, I hope I'm right. Yeah. I put as you need to construct a confidence interval to estimate the true mean, right? So we're still trying to figure out what the mean is, right? So we don't necessarily know what the mean is. So I put it as basically one sample t confidence interval because that's what they're trying to figure out. They're trying to figure out the mean of the 55 double stuffed Oreo cookies. And the way that they basically do that is figuring all the measurements and then figuring out what the mean is. And for a z confidence interval, you're either supposed to know the standard deviation or the mean. And I believe that for this one, you don't know either because you're only given the sample.
Okay.
If that makes yeah. So that's what I think. I hope I'm right. Yeah. All right. And then now we're on question number 9, and I'm sort of thinking it's B, but I'm not too sure.
A type 1 error is committed when you reject the null that is really true.
Okay.
Is the level of significant, like the sign for it, is it like the, I want to call it a fish. You know what I, like it is an A, but there's an extra hook on the top.
Oh, could you say that again, Wendy?
What's the sign for level, significant level? What is it? What's the notation for it?
Oh, the notation. So it looks like a fish. Like, you know, like how.
Does it look like a fish?
Yeah. That would be it.
Okay, so it also says, where did I read that? The true value of the fish, so the level of significance is committed. Oh, wait, is the probability of committing a level 1 error, so you are right.
Yeah? Okay, legit. Awesome.
That was all the way back to chapter 9.
It's nice. Well, that's something I'm definitely going to review because I have no idea.
For my page of notes, I print out the recap for each lesson and put it all on one page.
Nice.
I call my page of notes.
Yeah, good for you. That's awesome. Hey, whatever helps out, that's the best option.
So those are my other 2 tests. I won't take them to this one, but.
Very cool. I'll be honest, the only reason why I realized that one is that I think for one of the homework assignments, that's what I was looking for. That's the only reason why I think that's why I guessed that one. Yeah.
Okay. So question 10. Which one of the following best defines the notation? Oh, sorry.
Go ahead.
Defines the notation of p-value of a hypotenuse test. I'm just so excited to read tonight, I guess.
Okay. I think it's C.
Yeah, I think it's C also.
Yeah.
All right. All right, question number 11. Simon, would you like to read that one, my man?
Yeah. Suppose you create a 95% confidence interval for a mean and get 10, 20. You've been told to report this by saying something like, we are 95% confident that between 10 and 20. Exactly what does this mean? In every quiz, I always put this wrong.
Yeah, I'll be completely honest. It's me too. I always get this one wrong too. Yeah.
I always get confused with that question.
Because but it's confusing because you're thinking about C because it's all the data is between 10 and 20, or you think that it's 90% of the sample means are between 10 or 20. It kind of makes sense, but man, it's just kind of hard to grasp. I mean, I'm guessing C, but I'm not completely sure.
I won't say anything. Hopefully, Wendy.
I was just looking for a definition, but I'm not finding one in my notes.
Okay.
Because I don't know. I was guessing either A, when I was looking at these last night, I was guessing either B or D. So we've said all of the options now today.
Yeah, I mean, D does make sense, but yeah, it's pretty much. I'm not
For
completely
me,
sure.
for me, it's A.
It's A, eh?
Okay.
I don't either.
So, I mean, in one question I've heard them use, there's a 90% chance that the true mean is between 10 and 20. I think I've heard that. I couldn't give you a straight answer though.
I tried to look back on which quiz I kept missing that on just so that I could look, and I couldn't find it last night. Because you can look at the quizzes on what the right answers are supposed to be.
Really? Oh, nice.
Yeah, but I just couldn't find it.
Dang. All right. Well, I guess
for me, it's either A or C, or D. Sorry.
Or D.
Yeah.
Because it's the confidence interval is talking about the mean, not the data. That is like it's the sample mean is between 10 and 20, but I don't know if there is a chance or there's just the sample means are between 10 and 20. So that's why I confused between A and D.
Yeah.
That don't make sense. It's a chance or it's actually D?
I'm gonna put D, and then I was just gonna see what happens.
Sure.
But you guys deal with whatever you want on that one.
Yep. All right. I'm gonna go with D too. I think it might be D, but we shall see.
D too.
Okay. Awesome. All right. I'll read the next one. You take a simple random sample of 100 adults from Towin in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion of percentage of people in the town who invest in the stock market is P 0.30 or 30%. What is the mean of distribution of the sample proportion? So I think that one's kind of. Oh. Yep, I just got your message, Clinton. I'm gonna double check, my man. And yes, I definitely can see your notes, my man. Sorry. Yep, I see them, my friend.
So it's 0.300?
Yeah, I believe it would be that too. It'd be 0.300. Yep.
Baby.
Oh, so I think Clinton wants us to take a look at his notes. So he wanted us to take a peek.
I can't see the note.
Oh, you can't, eh? Okay.
No, I can't.
So I think that it's kind of hard for you. Do you see the little if you look at the left-hand corner at the top, do you see the chat right there?
I'm on my cell phone.
Oh, right. Yeah, that's right. Yeah, that would make it difficult. All right. Yeah, that makes sense.
Yeah, you're not. I wonder if it.
Population naturally. All right. So we will move on. Sorry about that. All right.
Oh.
All right. Okay. Question 13. What is the standard deviation of the distribution of the sample proportions? So this one we've used the equation. So I got 0.0456. Is that what you guys got, or?
.0456. Is that what we said?
Yeah.
Yes.
Awesome.
But it 0.046 is what I put. So I rounded to 3.
Yep. So.
Okay.
Yep, I believe it would be that one. Yeah, because I just rounded I did 0. I originally got my calculator 0.0458. I just rounded it up to 3. Yeah, that's it.
Okay.
Awesome. All right. So question 14. What is the probability that you will randomly sample 100 adults with will have a simple proportion less than 0.25? Okay. So looking at the probability, so I believe for this one you try to figure out the z-score. Is that correct?
Mm-hmm.
And then you put the z-score into the normal probability applet. So the equation as I have it written down would be z equals p hat take away p divided by everything being squared, p take away. So p times by 1 take away p. Yeah, it's just that equation for the z-score. Right there. Let's see.
So 13 was 0.046.
Yeah, that's what we got. Yeah.
Okay.
I'm just gonna double check to see. Yeah. Yep, that's what we got, Clinton. We got that. So 14. You stated that it's 0.138. I'm just gonna double check too. All right. So what did you guys get for that one?
I got 0.876.
0.87. Oh, for 14?
Yeah.
Yeah. Okay. So I got 0.138. And it's going to double check to see what Clinton got. Maybe I got it incorrect. Yeah, so Clinton also got 0.138.
Okay.
How much was your score?
So my z-score was negative 1.091.
Yeah.
Okay.
Okay.
All right. So Wendy, what did you get again, Wendy?
I did it last night though, so I couldn't even tell you how I came to this answer, but I got 0.876. So
No
I'm gonna go
worries.
with your guys' answer today.
Sure. All right. Do you want me to sort of explain a little bit how we got that? It's up to you. If you're good, then you're
Did you
fine.
do well? Did you just calculated in that big p hat minus p that right divided by the square root of the whole? I think I just put it in the computer. I put it in the applet.
Oh, okay.
So I
No
will
worries.
I will hand calculate it next time.
No worries. Yep, not a problem. That's awesome. No worries.
So you got. I have 0.138.
Yeah, that's what we got. Yeah.
Oh, me too.
Yeah. 0.138. Yeah. All right. Now we'll move on to the next one. And would you like to read that? I forget whose turn it is, but Stan, would you like to read that?
Yeah.
Awesome.
Acupril. Is that correct?
I believe so. Yeah, I think.
Acupril is meant to control hypertension. In clinical trials of Acupril, 2142 subjects were divided into two groups. The 1563 subjects in the experimental groups received Acupril. The 579 subjects in the control groups received a placebo. Of the 1563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of the people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. Create a 95% confident interval for P minus P2. Input the margin of error, lower and upper bounds below rounded to 3 decimal places. What is the margin of error for this 95% confidence interval? No.
So I got 0.016.
Okay, you got what again?
So I got, for that one, I got, actually I have to go back. Okay, there we go. So 0.016. That's what I got
That's
for
what I
that
got.
one. Yep, awesome. Okay, doke.
I got 0.016. Yeah, me too.
Awesome. Okay. And the other ones are pretty simple.
Yeah.
Yeah. Oh, go for it, Wendy.
Lower bound.
No, so just on the lower bound, it just 0 or negative 0.003.
Yep.
And then the upper 0.029.
Yeah, that's right.
Perfect.
All right.
Sorry. I got the lower bound minus 0.029 and the upper
0.029.
bound 0.003. Is that correct? Or vice?
You got, I think we got the same numbers. The only thing, I think the only thing that happened is that we got the negative 0.003. And then you got,
so I wondered whether you put the P1, who was your value for P1?
Oh, yeah. Yeah, that's right. Let me double check.
My P1 was the people that are on the medication that were dizzy. So 61 was X1, and then 1563 was N1, and then the next one was 15.
Yeah, but if you read I don't know how you say that, the instructions of the let P1 be the true proportion of people who experience this dizziness while taking. Oh, okay, sorry, my bad. I'm wrong. Okay, you're right.
No worries,
sorry.
Hey, we're all here to help each other out.
Yeah. Sorry, yeah. Yeah, you're right.
No
sorry.
worries.
No, it's all good. It made us all go back and look. It's totally fine.
Yeah.
Truth. I'm wondering, because I know that for the intervals, like, I know that you could go either way. I wonder if you did it the other way, if it would work. I don't know. I wouldn't recommend doing it, but yeah. I'm pretty sure maybe it would be the same answer. Hey.
Yeah, it doesn't answer the only like the you got the numbers with different signs.
Yeah, exactly. Yeah. All right. So, question number 18. Perform a hypotenuse test to see if the proportion of the experimental group subjects who experience dizziness is different than the proportion of control group subjects who did. Use a level of significance of 0.05. What are the appropriate null and alternative hypotheses? There we go. So I believe it'd be the first one. Because you're looking if it is different.
Right. That's what I got.
Yeah. Awesome. All right. Let's double check to see what. Yep. Okay. Awesome. Okay, we'll move on to the next one. What is your test statistic? Value of your test statistic.
.159.
Just a sec. Yeah, that's what I got too. I got 1.458. Is that what you guys got?
159.
Yeah, so I guess for that one I got 1.458.
That's what I got too from the applet.
Yeah, you're right.
No.
I'm saying the p-value. Sorry.
Oh, gotcha.
Oh, no,
That's
you got it
fine.
right, man. Then if that's the p-value, you're good. Yeah, so 0.145 that's great. 0.145. Yeah. There we go. Awesome. All right. So I think we're good for those two. All right. Question number 21. Wendy, would you like to read that one?
You got it. Is there
Awesome.
significant evidence to conclude that the true proportion of people who experience dizziness while taking that medicine is different than the true proportion of people who experience dizziness while not taking the medicine? So,
No.
Yeah.
You felt it.
Yep, I agree with you. I believe it's that one too. No, I failed to reject the no. It's a bit tricky because they put the alternative right there too. So if you weren't paying attention to that would mess you up.
So it's the last one?
It's the last one, yeah. Yeah.
Okay. They all of a sudden changed the wording on me and I panicked there for a second.
Yeah. All right, so next one. Would you have to read that one, Stylen?
So what was 21?
Oh, so we got the last one. So
Okay.
no, yeah.
I got that same one. So
Awesome.
Okay. Use the following information to answer the next 4 questions. A survey was conducted of 1279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypothesis test for this study was hypothesis age 0 being a morning or evening person is independent of age. A alternative hypothesis being a morning or evening person is not independent of age. The results of the survey are given here. Conduct a test of independence. Use a level of significance of alpha equals 0.05. Calculate the test statistic for this hypothesis test. Assume the requirements for the test are satisfied.
Okay.
So I got 6.579. Calculated.
Yep, that's what I got too. Yeah. All right. And then calculate the p-value for the hypotenuse test. So I got for that one was 0.0866. And if you just round that up, it would be 0.087.
Yeah.
So you guys, is that you guys got too?
Yeah.
Yeah, awesome. All right. All right. Question 24. You should reject You should reject the null hypotenuse or not. Should you reject the null hypotenuse or not?
No.
Yep, that's right. We definitely should. 1, 2, 3. I think it'd be D. No, the p-value. Yeah.
But it's greater than 0.0.
Yep. Awesome. All right, 25. What do you conclude based on these results? I believe it would be the last one. Is that you guys got too?
Hmm.
Mm. What did the? It's not infinite. Yeah. I think it's that one.
Yeah. Yeah. The only reason I say that. Yeah. Yeah. That's right. Just because you.
When we fail to reject, we have significant evidence, right? And so when
Yeah.
we reject, we have insufficient evidence. Yeah.
Yeah, that's right.
Yeah.
Okay.
No.
Hey, I'm good to get some clarification. I was a little at that point. I was just like, "Is that everybody got?" And I'm just like, "I don't know." All right. All right. Next one. Wendy, would you like to read the next one?
We're going to use this for the next 8 questions. A recent book noted that only 20% of all investment managers outperform the Dow Jones average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones and that average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over the 5-year period. Based on the results of the sample, create a 95% confidence interval for P. Input the lower and the upper bound below, rounding to 3 decimal places. Okay, I got 0.190.
Yeah, that's what I got too.
So, what test are you using for this one?
The one proportion test.
One proportion. Okay.
And I put 50 in for X, and then the N is 20.
Yeah.
And then the null was 20%. And then I put greater than.
So X is
50.
You said N 200.
Yeah. That'd be 200.
Oh yeah.
Yeah, this one's tricky because it just tells you the 50 in the sentence.
Yeah, there wasn't just a number.
Yeah. All right, and then what did you get for the confidence intervals, Stylen?
The lower bound or the lower bound is 0.190 and
Yep.
M. Let me calculate.
Awesome. Cavell.
But let me give you the M, but I don't think it's asking that, but let me give you that.
Hey, sure. Hey, go for
0.06. Sorry. 0.060.
let me double check. Yeah, that's what I got too. It's 0.060. Yeah.
But
for the margin of error. Yep, Covell. Hey, it's good. Good practice. Yeah. All right, so we'll move on to question number 28. And I think it's my turn. Okay. Suppose you had been in charge of designing the study. What sample size would be needed to construct a margin of error of 2% with a 95 confidence? Use the prior estimate of P equals 0.2 for the estimate. So for this one, I believe we just use an equation.
how is that should be calculated?
So
I made that wrong in the quizzes.
I believe
I don't.
if you actually go to lesson number 17, and then you right at the bottom, if you look inside of the pink tab right there, where it says at the end of the 5 summary, and it says remember. If you look right there, you can actually see the formula right there. So the formula would be basically n equals z divided by m. And then
wait. Let me get there.
Oh, no problem. Not a problem, man.
Okay.
No worries. Yeah, so the equation is just right, in lesson number 17. And if you scroll all the way to the bottom right there, just inside of the pink tab right there. You see that right there?
Yep.
Yep.
It says prior estimate of P. If no prior estimate is available, the formula, that one.
So you would actually, if you don't know the, so I think you'd only use that one if you don't know what M is. So since we do know what M is, I think you'd use the formula just right before that. So it has N equals Z divided by M squared. And then you do P times by, so P, first it would be P times by 1 take away P. And that's the formula that you would be using right there.
So the Z is with the star or asterisco, I don't know how to say that, should be the based on the 98%.
Yeah, that's right. So it would be based on the 0.95%. Sorry, it would be based on the convenience interval, the probability of. So if you put 0. Okay, so it would be based on the z-score for the significance level of 0.95. So the z-score for that one would be 1.96, I believe, for that z-score right there.
98%?
So actually, I might be able to help you a little bit more. I'm just gonna have to figure out where that graph is again. Just a sec. I just have the 95% significance level. I have the z-score memorized for it. Just a sec.
It's not 2.326 or 98%. I wondered. I don't know.
But
because I'm taking the number from the normal. I'm looking for and enter the number in the normal probability applet, and the value for Z score for that percentage is 2.326.
And that's for the normal one,
normal probability applet. I made it wrong, so I just.
Are you
I
shading
just want to know how to
part?
do it.
Yeah, no. Are
yeah,
you
the middle
part. The middle. Okay, and you put
Yeah.
in the top and the area 0.95,
Yeah.
and it's not 1.96.
One.
Yeah.
No.
I will share my screen and show you what I'm doing. Maybe then you can
Yep.
teach me and guide me how how bad I am. So
No.
You're not bad at all, man. Don't worry. You help us out plenty.
so I need to know because I made that wrong. I think in two quizzes. So
Mm.
I don't want to screw it
The one,
in the
one
test.
not a problem. I mean, the one thing that's really helped me, because I know that even if you basically put in the 90% the confidence interval, 95% confidence interval into the normal probability applet, it doesn't necessarily give you the number that you're looking for. The way I've always done it, this has helped me. I help you out. Is that I actually go to lesson. If you look at lesson number 10, and if you just go into that lesson right there, it'll actually give you the z-scores for the confidence levels. So if you actually go all the way down to there'll be a section which is called factors affecting the width of the confidence interval. So it'll actually just be right above that one. So it should be 4.2 factors affecting the width of the confidence interval. And just right there, you'll actually see the graph right there. That'll give you a better explanation. Hoping that helps out.
That and Stellan, on that applet that you just had open, at the top you put in 98%, and we're looking for 95%.
Here.
Yes.
98%.
95.
Okay.
0.9,
No, because okay.
0.95.
Okay. Yeah, 1 point. Yeah, in that case, in that sense, yes. But I wonder because they saying that's what confuses me. Is they using margin of error of 2%? Where do I use that 2%?
That one's in the formula under the M. In the formula from section 16. Is that the one I told you earlier? Oh, it's right here.
Actually, thank you, Wendy. That actually helped me out.
You're welcome.
I was just like, man, I'm just like, how do you figure that on the anomaly probability output? I'm just like, okay, 0.95. Click into the middle. There you go. You're good to go.
Yeah.
All right.
So on that 16, on that last, hold on. I'll just bring my thing closer. So that last equation, the M, the margin of error is what the M is.
Yeah.
Did I tell you the wrong one? I lied. Sorry, go to 17. I'm trying to move it on my phone. It didn't work. Okay, so on the fourth dot, see where it says Z with the little starry thing, and then divided by M.
Yeah.
So that Z is the confidence. So the 95 confidence, so that's the 1.96, and then that divided by M, which is the margin of error, which is 0.02.
Yeah, and the only thing that's saying is that both the z-scores, like the z-score on like basically the graph, is that it's 1.96 and negative 1.96, and that's basically the middle portion of what's on that graph right there. If that makes sense. Yeah.
I don't know. I'm still confused. Well, I don't know. Because I don't get it. Like the 2% confuses me.
Yeah, I'm trying to figure out what that 2% is too. But you just basically, I think if we look at that,
you use the 2. Sorry. You use the 2%. Okay, wait. The 2% in the margin of error, or the 2% with the P starry thing.
Yeah. Mm-hmm.
The P starry thing is for the probability. So in that equation, where it's the z and the m squared, and then there's a little part where it's like p times 1 minus p.
Yeah, that's right.
This one, can you? This equation, can you see it?
Yep. Yeah, that equation. So for this problem, when it's talking about the margin of error, that's the m on the bottom under the z, and then the confidence interval of 95 is the z, and then the m, then those p's next to that is that 0.2.
So in the place of m, should I put 0.02?
0.02, yes.
Okay, yeah, got it. Okay. Okay. So we use this formula as is. N equals, let me try. So P is 0.2.
Mm-hmm.
Okay. Oh.
And then round to the nearest whole number, and you've got it. I'm gonna need to take some Excel lessons from you soon.
Yeah, for sure. Man, so you're intense, bro.
Is that a big number, the answer?
Uh-huh.
Yep, that's right.
Yeah, that's what I got.
Yep.
Okay.
Man, good job with the Excel though. That's good job.
Thank you. I was lost with that one. Totally lost.
Nope.
The percentage confused me. The 2%, like, what the heck? Okay, got it. Thank you. What? So, okay.
All right.
Let's continue.
Number 29.
Okay.
Suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investments managers. Conduct a hypothesis test. Use a level of significance of alpha equals 0.05. Which of the following pairs of hypotheses is the most appropriate for addressing this question?
So I believe it would be the second last one.
Yeah, that's what I think.
Yeah? Okay.
Yeah.
Awesome.
Greater.
Yeah, with the greater.
All right. So question number 30. What requirements must be met to ensure that p hat is normally distributed? So this one's pretty simple. Yeah. It's the first one.
First one.
All right. The value of your test statistic is, let's go back. So I got 1.768. So you guys got 2?
That's what I got.
Yep. All right. So p-value would be.
Sorry.
Oh, they'll go for it, man. Sorry.
So what was the wow, sorry. So we are using what was the value we're what was the answer? Sorry.
So we got 1.768. Yeah.
We're back on the one sample proportion.
Yeah, it's just basically, remember we did the 50 I'm sorry. We did the 50, which was the sample, and the 20, which was basically the population sample. And remember we divided those both together in the Excel sheet. Yeah. So if you just look at the Excel sheet, you should get the statistic right there.
So the day are.
So yeah, it's just going off of what we got for when we started question number 26. Just for the the information right there was said.
So please, sorry again. Give me the number because I don't get it.
Yep, not a problem, man. Don't go for it, Wendy. Go
for the Z score. We've got 1.768.
Okay.
Do you in your one sample test proportion Excel thing? Do you have we have X is 50, the N is 200, the confidence level is 0.95, and the null hypotenuse is 0.20, and then the type of test is greater than.
The M value is what the number we calculated?
The N, no, that's what they just had given to us in the question of how many people they had sampled. They paused for a second and went to a couple different questions.
Yeah, that's why it's so confusing.
Yeah.
Yeah. That's why it's.
This is the info that they gave us right before question number 26, like Jeremy said earlier.
Okay, go ahead. I will figure it out. Okay, let's continue.
No worries, man. Not a problem. So I guess we'll go with question 33. Does that work out?
Yeah.
No. P-value?
30.
Oh, yep, p-value. Sorry. My bad. Okay. All right, so the p-value of your test, so I got 0.039. Yeah. Is that what you got, Wendy?
Yep, that's what I got.
Awesome. All right. Question 33. Is there sufficient evidence to conclude that the graduates from the top business programs perform better than the other managers? So if we look at the yes, there is. So yes, I'd reject the null hypotenuse.
For the first one.
Yeah. So it'd be the first one.
Yeah.
Okay. All right. And don't worry, Stan. We'll go back to those ones after, my man.
Okay.
We'll hook you up. All right. I know the next one's pretty long. Do you guys want to read it out, or you just kind of want to read it yourselves and try to figure it out? Okay. Well, we'll read it on our own. And we'll try to figure it out. Your software is commonly used to translate text from one language to another. Well, my Excel sheet kind of messed up. I'm gonna have to open a new one. Zero 0.295. All right. So, what did you guys get for the input, the lower bound? So I got for that one was 0.282. Is that you guys got? Or so Wendy, what did you get for that one?
Okay,
Oh,
what did you use? Did you use the one sample, or did you like the one sample T
yeah.
test, or
Yeah,
did
that
you use the one proportion?
so
One sample.
I just used the one sample t test.
Perfect.
Yeah.
Okay, so I got 0.106, but I don't think I have something in right. True mean population.
Differs from the other one. Bound 0.0.
Point. So the null hypothesis would be the other company, the other software mean.
Yeah, that would be it. Yeah, it'd be the 0.295. So leading the transfer software, which was a population mean of score of 0.295. Yeah, so that would be the null hypotenuse. Yeah.
So the type of test will not equal.
Yep, that's right. Yep, that would be correct. Yeah, that's what it says, right? Yeah, yeah, that's right. Mm-hmm.
The lower bound is the lower one bound is 0.282.
Yep, that's what I got. Mm-hmm. And then the upper bound would be 0.293. All right. And then for the input of the degrees of freedom, you guys got 99, right?
Yeah.
Yep. Awesome. All right.
Here, wait. What was the upper? Sorry, somebody had started texting me or IM me at work. What was your lower bound? One more time.
Yeah, not a problem. So for upper bound, so for lower bound, we got 0.293, and then for upper bound we got 0.282 for the first one.
How did you? What's in your boxes? So you put all of the variables in there, and then the mean.
Yeah. So the one tricky part is actually, if you look at the bottom right there, where it says which has a population mean score of 0.295, so you would actually use that as your null hypotheses. So you would put that in. Yeah. So you'd put that in there.
In the mean as well.
Yes.
So I put 0.5 just because it was. I just went with the middle between 0 and 1.
Oh, I see what you did. Okay. Yeah. So I think the mean that you'd be using would be the 0.295 instead of the 1 and the 2.
Okay.
Sorry, the 0 and the 1. Sorry. It's just
And then the
saying.
standard deviation is 0.95, and the n is 100.
Yep.
No, and then the confidence level is 0.05, huh?
Yeah. So it'd be
That's right,
0.05. Yeah. So it'd be.
Now I have
you
the
got-
right answers.
Nice. Awesome. Legit. Way good. Okay. So then we'll just move on to. All right. Wow. My mouse is way too fast right now. Okay. So inputting the p-value. What did you guys get for that one?
Test statistics?
Yep. Sorry. Input the test. Man, my mouse is going crazy. All right. So what did you guys get for inputting the test statistics?
Minus 2.803.
Yep. That's what I got too. And then the next one is pretty simple. Would be I got for the p-value would be 0.006. Is that what you guys got too?
Yeah.
Yep. Awesome.
What was the p-value? Sorry, one more time.
Yep, no problem. So we got 0.006. Okay. And then for 39, all right. Who would like? Actually, I'll go for it. Based on the results of this test, what would you conclude? Use a level of significance, which is 0.05. We have sufficient evidence to say that the true mean is different than 0.295. We have insufficient evidence to say that the true mean is equal to 0.295. I believe it would be the first one.
I would say we have insufficient evidence to say that true mean is different than 0.295. C.
Okay. I still think it would be the first one. I'm pretty sure. Let me double check. I
think it's equal. I think it's the last one. Because the not equals is the alternative.
Oh, no, sorry. No, you're right. It's first one. Because, yeah.
Well, no worries.
No. The thing is, we are rejecting the null hypothesis, isn't it?
Yeah, that's right.
We are,
yeah.
So if we reject it, we have insufficient evidence to say that the mean are different. So the alternative hypothesis says that they are different, so we don't have L. So that's why I think is C. We have insufficient evidence to say that the true mean is different than 0.295.
Okay.
Because the null hypothesis says that the mean equals to 0.295, and against the alternative hypothesis that says that the mean is different than that, than 0.295. So we don't have evidence to say, because we are rejecting. We are failing to reject. Or we are rejecting. No, we are rejecting. Yeah. I'm confused.
No worries. Because what I think is that you look at the p-value, which is 0.006. Yeah. So I think that. Yeah,
you're right. You have sufficient evidence because we are rejecting the null hypothesis. So they are different. Yeah, we are. Yeah, it's A. I think it's A.
Okay.
I'm with you now.
All right. No worries,
I'm
man. Hey, you making me think. That's good. I wasn't. That's I. Oh, I believe it's that. Yeah. All right.
Or if you call.
All right. Question number 40. Who would like to give that a whirl?
I study was done to.
Oh,
You
all
got
right.
it. Go for it.
Okay, I study was done to test a notion that people were taller. I mean, when they first wake up in the morning than in the evening, right before they go to bed. To test this theory, the height of children in a boarding school in India were measured. Values were recorded in millimeters for each child in the morning and again in the evening. The data is recorded in. You want to determine if the children are taller in the morning than in the evening. Define the difference as IM height minus PM height. Construct a 95% confidence interval for the true mean difference of height and conduct a hypothesis test at the level of significance of alpha equal to 0.05 to determine if the children are taller in the morning than in the evening. Input your answer below. The lower bound of confidence interval round your answer to the 3 decimal places.
Okay. So this one definitely would be paired sampling. Yeah.
Air sample test, p-test.
Yeah. I believe so. All right. So I got for the lower bound, I got 8.728. Is that what you guys got?
Yes.
Yeah. Okay. And how about for you, Andy? You got that? Awesome.
Yeah, 8.728.
All right, and then we obviously know what the next one is. It's 10.455. And then inputting the test statistic for this test. So it'd be 22.446. Yeah, okay. And then input the degrees of freedom for this test. So it'd be one takeaway from the actual number, which would be, so it would be 40. Yeah, so it'd be 40. And then input the p value for this test. Now, I'm a little confused because it's telling us an example of 0.003. But let's see. And they're looking if they're taller, so it'd be greater than, right? Are taller in the morning than in the afternoon. Determine if the children are taller in the morning than in the evening. So what did you guys get for the p-value right there?
It should be 0.00.
Yeah, because when I'm looking at it right now, I got like 1.39734 E, negative 24. Is that what you guys got also, or?
I have it if it's not equal to, but I think it should be.
Should be greater than, right?
For this type of two sample t-test, do we use actually one tail or two tails sampling? I don't know. Like, I thought that we only use not equal for this type of statistical test. You remember? Maybe I'm confused.
I think that what you're thinking is actually for the I forget which test is it for. It's actually for the it's the squared test, the CIHI squared test. I think that's what it states for that one. I'd actually have to double check though.
So on the paired, so the hypothesis is usually mu. The difference of mu, or the mean, is 0 between the two numbers, or the alternative is it's either greater, lower, or not equal to 0.
Yeah, that's right.
Okay.
This is what I have written.
Okay. So we should say that greater than the type of test.
So are we putting 1.397?
Yeah, that's what I'm debating, because it's asking. That's how I'm kind of confused, because I know I've done a question like this beforehand, and I got it wrong. Yeah. And I did the exact same thing. So I'm debating what exactly we should do. I mean, that's just one thing I just don't understand. Like, should we just put 1.397 and then just put E negative 24? That's my impression. I'm not completely sure. Because that literally is the p-value. Maybe we should just go for a wild guess. I'm not too sure.
Yeah. I always look at it like if it's less than, what does it do? If it's not equal to, what does it do? Less than is 1.
Yeah, I guess you could put it as 1. You're right, because I guess it is technically 1. Man, it's a good question.
I don't know if it's, there are no hypothesis. Is it because it's asking if the ones in the morning are taller.
Yeah.
So it all depends. So morning is in column, is variable 1, and evening is variable 2. So the difference.
Yeah, that's what it's saying. It's saying the variable for AM height, take away from PM height.
I don't know.
Yeah, I'm not completely sure either.
And however we answer this question is how we can answer the rest of the thing questions.
Define the difference as AM high minus B. Yeah, I think I'm kind of completely sure that it's 0.000.
0.000.
Yeah, because in the header of says define the difference as AM height and minus PM height. So the first mean is in the morning and the second mean is in the evening. So the data, you should place it in that order. So if you say greater than, would be
It'll be all zeros.
Mm-hmm.
Yeah, because I think that's because it's still going to the power of negative 24. Or the exponent, sorry, the exponent of negative 24, right? So it's like a whole bunch of zeros then leading up to that 1.39734, right?
Mm-hmm.
Mm-hmm.
So, and it's tricky to answer a question like that because do we just put it as that or we just put it as 0.000? Yeah.
I had in another Cairo and got the right answer.
Oh, you put it at 0.00 and you got the right answer.
Yeah.
Okay.
It was correct.
Awesome. All right. Well, then we're good to go.
Yeah.
All right.
So based on your results of this test, is there enough evidence to suggest that the children are taller in the morning than evening?
No.
No. Or yes?
I think it's no, and we reject the no.
I think it might be yes, just because if you look at, I mean, I could very well be wrong. I don't want to leave you down the wrong path, but my impression that would be yes because the p-value is to the exponent of negative 24. So even though it may be 0.000, along the way of the 24 zeros, eventually you will hit a 1 or you'll hit a 3 or you'll hit a 9, right? So I believe that would. So I believe that would be yes, because we reject the null because the p-value is very significantly small. That's my impression. You guys very well could be right.
I take my no back. I change it to a yes because it's just asking if we have significant evidence. And because the p is low, we have significant evidence. So then yes.
Okay.
And then we reject the no.
But hey,
we reject.
I don't want to leave anybody astray though. For sure. But I guess that would be it all together. Did you guys have any other questions regarding what we did so far? I know, Stan, you had there's a question that you wanted to go over again. Is that true? Or
I will figure it out by myself, and will help me to study.
Okay.
I have to take an exam right now from studies from accounting.
Oh wow. Okay.
So
well,
I need to take that. And actually, yeah, that class is kind of hard for me.
Yeah, I can imagine. That one's probably way different. That's why you're so good at Excel, man. You're using those skills, my brother.
I need to go through that. And my kid's still awake.
What time is it at your house?
9 o'clock.
9 o'clock at night?
Yeah.
Gotcha.
So
well,
hopefully
best
they
of
go
luck.
to bed. Yeah.
Well, I guess. Is there anything?
Well, yeah. In my regard, I'm okay so far. So
okay.
I would say thank you for all the explanation I received. I can solve that exercise. I was very confused.
Not a problem, man. I get confused all the time.
You guys are good. Hey, we will see you next week. I don't think we have anything the rest of this week.
Yeah, that's right. That's it. We just have to do the exam and that's it. But Wendy, did you wanna talk about the project, or did you want me just to talk to basically Brother?
No, I can talk to you about the project. That's fine.
Yep. Okay. So I know that we are saying that we might make sense of it after we did this practice.
Yes. of how
Do
many
you-
we needed to do.
Yeah, so we were debating we were debating how we're gonna select the sampling. That's the only thing we were debating. Yeah. I
Okay,
mean,
so as we've done this test, my one other question is it one sample test and not a proportion? Because
Oh.
I will have data from each school.
Mhm.
It's one sample test.
Yeah, that's right. How would you interpret that into proportionate? Well, it should be. Yeah, it would be one proportion. It wouldn't be two, because what you're trying to determine is out of the population of students, you're trying to determine how many liked. Let me double check again. Yeah, so we're trying to determine what percentage of students eat fish sandwiches, right? So that's the only percentage that we're looking at right now. So when you basically look at all the data, you'll just be looking at the number of people that liked fish sandwiches out of the number of people. So I guess
would it then be just X well, if we did the one proportion, would X just be however many people selected fish, and then N would be how many people were served through the whole district that day?
Yep, that's exactly it. That would be it. And there definitely will be most of the majority of students probably most likely would go for pizza. Yeah.
Pizza. Or just fish.
Yeah, I think that's what Brother Bennett stated, right? Yeah, so that's pretty much what we're going to be working with, is that we're not going to worry about the pizza whatsoever. The only thing that we'll be, if we really wanted to, we could, to make it even better, you could figure out the proportion of who basically like pizza and the proportion of who like fish sandwiches. And then you could do a two proportion if you really wanted to. But I would say just go with what the teacher said.
Well, yeah. And he asked the question of, well, when you come up with all this information, what are you going to do with that? So,
that's what he said. Okay, so
it's cool that you come up with this, and he goes, and honestly, if you do a two proportion, the kids are gonna choose pizza way over fish anytime. So he goes, so I would do the one proportion test and kind of make your null hypotenuse, whatever that thing is. If it's less than 20%, then you no longer serve that product. I was gonna check with my boss what percentage, so there would be an outcome from this, and this will help later in the next parts of the study when it's you're making inferences and coming up with a plan or something, whatever has to happen in the next two after we collect the data. So that's why. So the one sample t-test is what he said, so that then afterwards you can come up with, if only less than 20% ate fish sandwich, then we're going to no longer serve fish sandwiches.
Yeah, that makes sense, because what you're doing is that with the null hypotenuse would be the 0.20. So yeah, you're right. So then when we put that basically into the Excel sheet, and then we have the number of the amount of people that basically take fish sandwiches. The total sample number. And then we have basically the amount of people that took them. If it's less than 20, let's say, for instance, if it's 15%, right? Our p-value would be far less than 0.95, right? Because you're looking at basically the null hypotenuse, which is 0.20, 0.20, right? So our range for basically intervals would be sort of in that percentage, right? So it would be between the number of mean that is between, for instance, it'll give us the convenience intervals, right? And then when we figure out those convenience intervals with the, I'm trying to make sense of this, trying to explain it perfectly. When we have the 0.95%, which is the level of significance, we'll figure out the significance level and the intervals on each side. And then we'll be able to figure out if we are going to reject it if the p-value is less. If the p-value is less, then we know for sure that basically we can reject the null hypotenuse, because the null hypotenuse is 0.020 because it's 20%. Does that make sense? So then we would be able to understand if we can reject it. And then we can say there is a significant amount of evidence that in the population that only less than 20% of people like fish sandwiches. So we would basically reject the null hypothesis and state that, this evidence indicates that we should basically no longer serve fish sandwiches because the percentage of the amount of people that like fish sandwiches is lower than 20%. Does that make sense?
Yeah. Yeah.
Wonderful.
So
yeah.
You would put the proportion of fish sandwich eaters, I don't know, or proportion of fish sandwich, you know what I mean, there.
Yeah.
And then is equal to 20%. And then on the null, or the alternative would be the proportion of fish sandwiches is greater than 20%.
So yeah, so for that one, that's a good question. Let me double check. yeah. Yeah. So yes, that would be right. You're right about that. It would be less than basically the 0.20%. If we go with the p-value and the p-value, so for instance, you're right. We would do that way. We would basically in the Excel sheet when we're calculating up the data for proportions.
Mm-hmm.
Yes, you are correct. So we would basically do for one proportion, it would be less than, yeah, because you're trying to see if basically it's less than that 0.20%, and if it ends up basically if you calculate it up and the percentage is far more, let's say for instance the p-value is far higher, then we know for sure that the percentage of the amount of people that like sandwiches is higher than 20%. So therefore, we have insufficient evidence that we can reject the null hypothesis, right? Because it's far higher than the 0.21%. So we know that the percentage of the amount of people that like it, it's more than 20%. So we can't reject it. So we keep on distributing it out. And the one thing we can say in the conclusion, and this will be basically the PowerPoint presentation. If it ends up being actually less, what we can state is that it's far better for us to basically no longer serve out fish sandwiches, because we would save more money just by distributing pizza, because more people like pizza than fish sandwiches, right? So if you did it that way, then for instance, your school would be saving more money. So does that make sense? All right. Awesome.
So
but thank you. Yeah.
That we're in question 8. What are you wanting to do? You were talking cluster earlier, but I still just think the cluster sample is just our cluster. Our cluster is a sample of all 27 schools.
Yeah, you're right, because you're just selecting a specific amount out of all those schools, correct? Out of all 27 of them.
Yeah, I was just going to take all 27, everybody that was served, and get the numbers there.
Yeah, that's fine, because you're splitting those off from 27 groups. And I think that if you just take a proportion of, say that you take a whole cluster of maybe 400 from each, you should be fine. I think that would be compared as cluster sampling.
Okay.
But maybe we might make it a little bit, yeah, you're right. No, I think that's okay. I guess
you're the one typing it in there, so as long as it makes sense to you, I'm good with that.
Okay. All right. So I think maybe from that, I'm definitely going to still probably talk to Brother Bennett for sure. I think from that is that the only thing, do you know for each school, how many students are in each school, like on a regular?
It all varies. I can give you a better range. I'll look at it tomorrow, but just off the top of my head, there's anywhere from 200 served to, I think our highest school serve is about 650.
650. Okay, that makes sense. So I guess we might have to go from a range in between that number, just making sure that we have all the students, right? Yeah. Just because if you
all the schools, I would seriously going to do a running total until of,
Yeah, and I think we should be fine because we're taking a large amount of numbers, and I don't think it has to be. We have to take all the numbers from each school, right? I think that if we're taking a whole bunch of numbers from different schools, we're taking a clustered amount from each school, so the population would just be in general. But so the districts, you have 27 schools, right? What district is it over?
It's over Weber School District. So,
Weber.
So that's 7 elementary schools. We have 20. We have other schools. A total of 43 sites. 44 sites.
44 sites. Oh wow. Okay. All right.
Are there those elementary age?
Okay. Then I think that we should be good. The only thing that we're probably going to include is that for our test, we based on Weaver schools. Wow, I was thinking about something else and it completely went away. But I'll talk to Brother Bennett, and I think that we should be good. I think that cluster should be fine, and we will do that.
Okay.
Yeah. What was I thinking again? Wow, it came to my mind. So what we're saying in our test, yeah.
We will, let's see, the question was, will our project involve human subjects? I changed the answer to yes, but I would almost still put it as no, and just say that we're collecting data that's already, like, we're not talking to the students. I don't know. Yes is fine too, but they will. But that's why we had the I
don't know.
Oh, but because our study in
Maya.
Could you repeat that again, Woody?
On that number 11, I would almost change it to no, and just say
yeah.
We are not using but because our study involved students 5 to 12-year-olds that we did involve the is it IRB? I want to call it IRB that I wrote earlier. Yes, IRB.
Yeah, so I guess what I'm going to say is that I'm going to put no. We are not using human subjects, but we are using data that has been collected
on children, on children. Students ages 5 to 12.
And I guess when you submitted the study, they said that we were approved for it, eh?
They did, and that email that I emailed you with, that was the approval that I got back.
Okay, that makes sense. That's awesome. So we'll just probably follow that every step of the way. Mm-hmm. So that'll make it easier for us. Yeah, okay. Please identify primary address, other research project you're planning, other. So I guess, did you fill out that information, or did they just basically help you out with that?
All the end stuff?
Yeah, like for the so the response summary, or for number 5, I said, what type of research project are you planning to conduct? It was other. But they did.
I typed all there.
Ah, okay, I see. That makes sense. But that's fantastic. If they approved it, then I think we should be good to go.
Yeah.
Yeah.
Yeah, we just have to go through the professor.
Yeah, that's the only thing.
And I think he said, just as long as we got it through the IRB and we still presented it the same, like that, he would approve it just fine.
Yeah, so and he, if he really wants us to, we can just basically attach the same statement to him just to make sure it's approved.
Mm-hmm. Yeah, you're more than welcome to use whatever I wrote there to.
Yeah, I'll talk to him about it, and I'll definitely hand this in before the end of the week. Make sure that it's submitted through. Yeah.
Need me to email it through, and I'll let you know.
Yeah, you know what? I'll email it to you guys, just to make sure if everything is okay. But I'm definitely still gonna talk to brother Bennett, because I'm not completely sure. I want to know for sure, like, how we're gonna sample um, the people. But I'm sure, Wendy, you go ahead with sampling right off the bat, because you need to get some numbers, right? So you go ahead and do that, and then I'm just gonna clarify with him to see if everything's okay with what we're doing.
And I will try to email you like just what I pull tomorrow, and then so you can have that, so you can like you'll have more like the data in your hand, I guess, at that point.
Yeah, that's perfect. That'd be great.
Okay.
Alrighty then. And I guess maybe we will touch base on Thursday, for sure. Yeah. So if you guys all want to work, if we can touch base on Thursday, that would be great. If you guys wanted us to talk about the project and stuff, and then we can discuss about it. If that works.
Would be good.
Yeah.
Would be good.
Well, guys, I think that's about it. I will let you guys know what's going on.
Perfect.
Right.
Okay.
Well, guys, good luck in your exams.
Yeah. Thank you.
Hey, take care.
Bye-bye.
Bye.